So in this video, we're going to look at how to find the nth degree Taylor polynomial for cosine of x centered at 0. So first thing we do is we evaluate our function at 0 to see what we get, and we get cosine of 0, which is 1. So that'll be our very first term of our 0th degree Taylor polynomial. Now what we're going to need are the derivatives to find out what its first, second, third, and fourth Taylor polynomials are going to look like. And with a lot of these, you just need to go far enough till you see a pattern. So f prime of x is negative sine of x, and then you evaluate your derivative at the point you're centering the Taylor polynomial. So f prime of 0, negative sine of 0, which is 0. F double prime of x, derivative of negative sine is negative cosine of x. Evaluate that at 0, we get negative 1. F triple prime of x is a positive sine of x. The derivative of negative cosine is positive sine. So f triple derivative, third derivative, at 0 is 0. The fourth derivative at x, the derivative of sine, is cosine. The fourth derivative evaluated at 0 is 1. And now you're going to start to see a pattern. Notice we're back to cosine of x, and then this is going to repeat. 0, negative 1, 0, 1. 0, negative 1, 0, 1. So I'm not going to go any further with that, but if you want to test it, you can. But notice we're right back to where we started. So if we go to build this Taylor polynomial, let's see what's going to happen. Notice, if I wanted to build the first degree Taylor polynomial, well, I have 1 plus 0 times x, so 1. So every odd Taylor polynomial is going to have no advantage over the even Taylor polynomial. So let's take a look and see if we can make this a little bit more obvious. Let's look at the second order Taylor polynomial. We know it's 1 plus 0x, I'm not going to write that, minus, so negative 1 times x squared over 2 factorial. Okay, this is going off our formula for a general Taylor polynomial. Now my third degree Taylor polynomial for cosine of x is actually going to be the same as the second. The reason is because the third derivative at 0 is 0, so it's adding nothing to the polynomial. We're getting no more information. Right? It's because of the behavior of cosine of x. Cosine of x is an even function. Notice we're only going to keep the even degrees. P sub 4 of x is 1 minus x squared over 2 factorial, it's the second degree, plus the fourth term, which we know is a positive 1, so plus x to the fourth over 4 factorial. Now this is going to be the same as the fifth degree Taylor polynomial. Now let's say we want to generalize this. Notice we're only keeping the evens, and we'll say that we're coming up with a formula for the nth degree Taylor polynomial, and we'll figure out where to start it here in a second. Notice we only want to get even numbers, and whatever the exponent is the same thing we're taking the factorial of. So x to the 2n, we'll keep that even, over 2n factorial. And this is going to go from 0 to n, and I shouldn't be using n twice, excuse me. Those should be i's. Okay, we shouldn't be using n here and in here. The other thing you should notice, negative, positive, this is going to be an alternating series. So I need to put in a piece for the alternating nature. So negative 1. And I got to decide what n should be to. Notice it's going to be start off at positive and then go negative. So I can go ahead and start it to the I. Because at 0 it's going to make it positive, at 1 it's going to make it negative. Those twos are going to make sure that we always have an even number. So this will find our nth degree Taylor polynomial. If we let n go to infinity, we'll have the Taylor series for cosine of x centered at 0.